Good morning and welcome to the 2021 SIL LightBytes online series. My name is Bob Bohannon. I'm the current SLL president and I'll be chairing today's session. Before introducing the speakers, I'd just like to run through some housekeeping notes to help make this event run more smoothly and to be more productive for you. If you're experiencing any difficulty in hearing today's webinar, we recommend leaving the session and logging back in. Other browsers, of course, exist, but we have found that using Google Chrome as your browser, the session is likely to run reliably. At the end of today's presentations, there will be an interactive Q&A session, so we encourage you to leave your questions on the chat function. Of course, today's session is CPD accredited and forms will be sent out. Today's LightBytes will be recorded and links to those recordings will be shared after the session. If you'd like more information about the Society of Light and Lighting, please visit our website, www.sil.org.uk, or contact SLL@CIBSE.org. Now, with the housekeeping out of the way, we can introduce this first in the 2021 series of LightBytes online. As I said, my name is Bob Bohannon. I'm the president of the Society of Light and Lighting. And my job as president is to help the society continue its amazing work to deliver safe, zero carbon, healthy, sustainable, comfortably lit, and visually stimulating environments. The COVID-19 lockdowns temporarily cut CO2 emissions, but it also triggered huge economic contractions. Now, some governments are harnessing their economic recovery to plans to boost low carbon design and technology. They call this Build Back Better. But will the requirement to deliver net zero carbon buildings place energy efficiency above all other lighting criteria we think are important? Well, I hope not. Thus, this LightBytes series is titled, You Can Have It All. Minimum energy, minimum resource, maximum comfort. This four-part series will explore methods of addressing the unavoidable need to pursue a new approach to lighting, one that considers product design, manufacturing, scheme design, installation, maintenance, and waste. The Society will be joined by expert speakers from its sponsors in partnership. Steve Shackleton, Lighting Applications Manager at Fagerholt UK, Hannah Looms, Head of the Trilux Academy, and Tim Bowes, Head of Lighting Applications at Whitecroft Lighting. The first session is examining, or this first session I should say, is examining the topic of minimum energy. And our first speaker is Tim Bowes of Whitecroft Lighting. Tim is a member of the Society of Light and Lighting and is Head of Lighting Applications at Whitecroft Lighting. Tim has been involved in the lighting industry for over 18 years with experience in lighting design, product development, and training. He's actively involved with the lighting industry, being Vice Chair of the Lighting Industry Association's Technical Committee, and was a member of the task group who recently published the Society of Light and Lighting's Lighting Guide to Hospitals and Healthcare Buildings. And he's also now an advisor of the light concept for WELL. Tim's presentation this morning is entitled Minimum Energy, Going Beyond Luminaire Efficacy. Tim.
Thank you, Bob. Thank you, everybody, and good afternoon. I'm just going to share my screen. So hopefully that could be seen okay. If that's okay, Bob, if you can just confirm, or Juliet.
Yep. You just Great. Need to, that's it.
Yep, great. Okay, so thank you. Yeah, it's great to be able to kick off the SLL LightBytes series. And as Bob mentioned, I'm going to look at what can we do going beyond luminaire efficacy. Luminaire efficacy absolutely is a key to what we do in design and delivering low energy solutions. But yeah, I want to look at maybe what can we do beyond that. And we've made incredible strides in the last 10 years as an industry in delivering significant energy savings. And if you take the example of a downlighter, we're delivering nearly 3 times more efficient lighting solutions than was possible 10 years ago. And if we look, and published in the UK Green Building Council documents Embodied Carbon Developing a Client Brief, in 2012, they reported in 2012, 78% of the total built environment emissions were for operational usage. So clearly what we've been doing within LED and control technology up to now has made great strides in driving this energy, operational energy down even further. And of course, for us within our industry, LED has become the default, both on new build projects where it's become, I guess, a no-brainer almost to deliver LED solutions. And I think everybody on this webinar would only be specifying LED technology unless there's any very specific needs. And of course, not just on new build, but on existing businesses and existing installations and projects where the efficacy improvements and the reduction in cost that's happened over that 10-year period has meant, if it's done correctly with the right quality of products, they can realize a return on their investment through reduced energy bills and improved maintenance. But I think it's fair to say, though, that this payback point in time, was often the deciding factor in investing in LED technology. Sometimes this was arguably done. I think we've all seen examples where it's been done at the detriment of light quality and of the wide environmental impact. But these are things we'll pick up on the next couple of sessions. But I think the discussion we're certainly having is changing. We're seeing maybe a change in the approach, and businesses are moving away from just simply looking at the financial reasoning behind going to LED and looking at their wider aspects around their wider sustainability needs, about both their environmental impact, about the operational carbon that they're using, and ultimately going to their net zero targets and aspirations that they have on top of their sort of wider goals around their corporate social responsibility and their environmental social governance. So yes, whilst there's still a financial reason to potentially move to LED, the discussion around the environmental impact is also growing as well, and the operational carbon that people are using. And of course, the other thing we have to keep in mind is, whilst we made great strides in the last 10 years around energy efficiency improvement, if I turn that top chart into a slightly different graph, you'll see that improvement is slowing. We're not going to be able to keep delivering that fantastic energy saving that we've done over the last 10 years as the technology matures and starts to plateau out. So what I want to talk about today is looking about what can we do beyond luminaire efficacy, not losing sight of luminaire efficacy, and absolutely it's still important, and there's still things we can do within design from a luminaire efficiency point of view, but look at some of those other aspects as well that we can do that maybe don't always get discussed within energy decisions and considerations in projects. And I want to do it around an example of a project that we've been working on probably about the last 18 months at Whitecroft, where we were asked to take and work with a client on essentially taking a school project and taking it off the grid. So they wanted to deliver the most energy efficient lighting solution they could, because they wanted to use fully renewable energies from site. So as part of the net zero aim was making sure the operational carbon or operational performance was as low as possible. Now, yes, we had to meet the budget and we had to try and work to that. But in the first instance, it was about looking at what was possible and then working how do we then fit that within the budget. And the great thing is a lot of what we looked and tried to do is being implemented into the end projects. And we had a target of reducing 40% lighting load. And this wasn't from T5 or T8 lighting solutions. This was taking a good LED solution and taking it another 40% on top of that. But of course, we couldn't lose sight of the importance of compliance. Now, we have the priority school building specification Annex 2E that requires us to not just consider horizontal illumination, but also consider wall illumination, ceiling illumination, cylindrical illuminance, UGR, all those key metrics that are important around delivering great lighting spaces for people to learn and to develop. And just one example of why this was important for the customer and the client was, for example, in corridors, they insisted that we still maintained and kept a linear asymmetric corridor solution, because they understood the value of delivering good quality lighting into these transient spaces and how that made people feel in creating the well-lit, safe environments. And I guess maybe education has different challenges than perhaps you might see in commercial, where we can't necessarily look to maybe provide task lighting. We have to provide these general sort of uniform arrangements and layouts of blanket lighting levels across classroom environments to create the flexibility needed going forward. And yes, we did talk about going down a task lighting approach, but the way these spaces are used today, that maybe didn't fit quite with the model that people were looking to do. So what do we do? What do we undertake? You'll see on the bottom, some examples of some of the activities that we did, and I'll talk in a bit more detail about these as I go through this next this slide here. But obviously we needed to benchmark and know where we stood in the first place, because we're going to offer a saving, we had to understand what we're doing. And so from a general lighting point of view, we were at 4.2 watts per meter squared. And this isn't per 100 lux, this is actually the actual watts per meter squared. No, this is probably still 2-3 times better than what would be required within Part L, for example. So no, so we still had a good starting point to go from. So what do we do? So the first thing we did is we looked at making sure we're using the best LEDs we could. So we looked to use a technology called flip chip LED technology, and this is a more efficient LED. And what they've done within this is a couple of examples of what they've done within the technology is really think about how the LED is impacted by the environmental contaminants that could be in the atmosphere and in the environment that these go into. So, for example, they removed the need for a wire connections within the LED to reduce that environmental contaminants. They look to include a protective coating onto the LED components to ensure better reliability. And also they included an internal reflector inside each of the LEDs as well to help optimize and get the maximizing the energy efficiency and the performance of the LED. And this gave, as you can see here, just straight away goes to 10% improvement just by looking at a better quality LED light source. And still looking at luminaire efficiency as one of the metrics we could go further on, we then looked at just taking natural efficiency gains. We started this project in 2019, but this project wasn't going to be delivered until 2021, 2022. So whilst that efficiency gain was maybe slowing, it was still happening. So we wanted to make sure we were using truer, more accurate data for the point at which the building was going to get handed over, rather than figures that were relevant for 2019. So we can look at the roadmaps of our suppliers and project where the LED efficiency would be. Again, another big win was then looking at the environmental impact. So this efficiency improvement we saw here from 3.7 to 3.4 was pretty much only taken in considering what was going on in the classroom areas. So yes, whilst this was half the energy, it still had a large impact on the environment. And this was about helping the client understand and ourselves understand the impact that things like reflectance values can have on the scheme. So rather than just using the default 70-50-20 or maybe getting dictated what the reflectances would be in a space, we were trying to encourage the use of higher reflectances and let the environment that the space was in contribute to the lighting levels that we had. So for example, encouraging a high ceiling finish of up to 90%, encouraging light carpets, light furniture to ensure the floor cavity gave the contribution back into the lit environment to deliver that overall lit effect and the overall lighting levels. And you can see here the impact that can have, and maybe encouraging and making people aware of what the impact can have around it. Reflectance values could be a way of driving through efficiency improvements, rather than the encouragement that we see today of using very dark, low reflectance values, what the impact can be on the energy side of things, as well as other challenges about things like glare control, etc. And the next thing we then looked to do was not just around luminaire efficiency improvements, but actually looking at technology around drivers. So in the dimmable areas, we were delivering a maintained illumination level. So the light levels would be commissioned to factor in the reduced output required, or the energy required on day one to factor in the maintenance factor. But what we also then started looking at doing was in non-dimmable areas, so toilets, storerooms, plant spaces, where traditionally we wouldn't put daily luminaires into. We encourage the use of CLO drivers, constant light output drivers. Now, I know Steve will go into a bit more detail on the technical side of things, but essentially what this does is it sets the light level to be at the point you require the levels to be at to deliver the maintained illumination value, then over time increases the energy gradually to ensure the maintained value is delivered. But it adds an additional energy saving into the scheme and into the project. We then looked at updating the products. We wanted to make sure that, one, we're using the best in class. So if we're using a downlighter, what can we do to make sure we're using the best possible downlighter in a space? The same for the high bay products, to make sure we're optimizing the energy efficiency of those products. But what we could also do within these spaces, and what LED technology allows us to do, is fine tune the output. So we can make sure that, we have the standard size classrooms. We can make sure the outputs we were proposing for each of those 4 or 5 different size classrooms was the correct output to deliver the optimized lighting solution for that space. There was no wasted energy or lumens into the space as well. And finally, we looked at innovation. Now, we looked at how can we improve the efficiency away from just the light source, but what can we do to the luminaire to drive the efficiency through? And we looked at 2 of the biggest areas of consumption of energy in a space. We looked at the classrooms and the circulation. And by utilizing the flip chip technology you already talked about before, by utilizing the best optics, by utilizing high reflective finishes and internal reflectors, for example, we could derive the efficiency from the products. We took the classroom fitting, which is already very good at 133 luminaire looms per watt, and pushed up to 176 luminaire looms per watt, still delivering glare compliance and all the other important metrics. And within the circulation spaces, we took it from 109 luminaire looms per watt up to 177 luminaire looms per watt. So hopefully what you can see here, a mix of, yes, also luminaire efficiency and driving that through, but also look at some other areas that maybe we don't always consider. We could really drive that efficiency through within the scheme, just looking at it at a watts per meter squared basis. But what we then did is we then said, well, watts per meter squared only tells us part of the story, because actually what we want to be looking at is how is the space used and how is it actually performing from a operational point of view. So we started looking beyond watts per meter squared and looked at the kilowatt hours within the space and the environments. And so we took typical school hours from guidance documents such as BS 15193, which typically says a school is circa 1,800 hours a year of operation. Okay, some people may debate it's more or less, but that's a figure we use just to benchmark the scheme. But what we then also started to realize and identify was, taking 1,800 hours is fine for maybe for classrooms or those continually high operating hour spaces, but it doesn't necessarily apply across all spaces. So we then broke it into the 7 different environments you can see here. So classrooms, assembly spaces, circulation, WCs, office meeting spaces, kitchens, storerooms, and we then applied a reduction, an additional sort of operational reduction factor based on 15193 about how these spaces are operated within an environment to really drive down the energy and give a truer reflection of how these spaces are applied. So for example, storeroom, despite 1,800 hours a year for a school, a storeroom might only be say a couple of hundred hours a year of operation. So it gave a truer reflection of how the spaces were performing. And this got us to a 35% energy reduction from the general lighting. So we had about 30% reduction looking at just purely the watts per meter squared, but when we start looking at the kilowatt hours, we could then drive that further down to a 35% reduction. So it gave us a slightly different number and figure. And from here, we then started looking at other elements as well. We started to challenge, for example, although it's not included in the numbers here, we looked at why do we need to provide 500 lux all day, for example, in the science lab? Could we, when it's just undertaking simple desk-based tasks such as writing, could we maybe provide 300 lux and then provide 500 lux for the task activities? Again, not picked up in here, but we started to change some other things we could maybe look at doing when we started looking at how the spaces were used and the operating hours that were undertaken. So what you can see here then, so this is those 7 areas broken down. So you can clearly see that the 2 biggest energy consumers, even with that very high efficient solutions, was the learning spaces and the circulation spaces. So the biggest, over 50% of the lighting load for the total project. But what this also shows you, this graph here, this pie chart, is there's a third of the total lighting load missing. That when we started on this project, we weren't asked to challenge or weren't asked to look at. And if we just left it as it was, we would still be looking at a third of the lighting load, and that's from the emergency lighting and the controls within the scheme. So the emergency lighting was nearly, if we just left it with the standard traditional technology we use today, was nearly 23%, nearly a quarter of the total lighting load on the scheme now was the emergency lighting. 3,000 kilowatt hours was on controls. So whilst yes, controls give us great energy saving reduction to make sure lights are turned off when they're not needed, they do take a load of energy. They to function and operate in an appropriate way. So we had to make sure we looked at challenging these elements as well. And this was a bit of a surprise when we presented this to the client about other aspects of the design that we need to be thinking about. So just for the last sort of 2 or 3 minutes, just the next couple of slides, I'm just going to focus on what we can do around the emergency lighting side of things. And so this scheme here was using traditional NiCad batteries, or the previous scheme was using NiCad batteries. And on this school, we had about 450 emergency light fittings. So it's a large secondary school. All classrooms had a minimum of 2 emergency. We had circulation, meter rooms, all those different areas that we have to provide emergency lighting. So 450 emergency lighting points. And typically a NiCad takes about 2.2 watts of power for each luminaire, running 24/7, 365 days a year, minus the testing and the duration and recharging at that point. But a large consumption of energy being taken there. But if we moved away from NiCad and we still keep it as integral emergency systems, that's what's required on this project, rather than looking at central battery systems. If we move to lithium iron phosphate batteries, we could reduce that load down from 8,700 kilowatt hours down to about 4,900 kilowatt hours. So a saving of about 45%. So often we talk about lithium iron phosphate batteries around the benefits around maintenance and reliability and the potential for recycling in the future, but actually there's also a huge energy benefit as well that we can look to apply into our projects. If we then still keep it within integral battery environments or solutions, and we look at maybe the standalone solutions, so the small LED heads that we now see, because we can reduce the quantity in areas such as circulation spaces, we can take it down another 15% reduction in quantity, take us well below less than half of the energy consumption from the emergency lighting system by using a standalone solution. So really driving the energy much further down. Again, I have included central batteries systems here because that wasn't part of the project that we had today, but looking at some of the central battery systems, this energy consumption from some of the figures that I've been provided with, we look, I think, between 2 to 10% of the equivalent lighting load from a NICAD by looking at central battery systems. So if we're really going to drive operational carbon down, emergency lighting could be a way that we could look to do that and innovate going forward into the future. So just to sort of reflect and just sort of reframe that pie chart now. So the general lighting load is now nearly 80% of the lighting load, with the emergency down at 13%. Still a significant chunk, and still probably the second or third highest energy consumer in the space, but certainly looking much better than it was previously from a consuming element, giving us a reduction of nearly about 19,000 kilowatt hours with a saving of about 36%. So we got back down to where we were from the general lighting by also addressing the emergency and the controls to a smaller extent going forward. So not quite at the 40%, but it certainly gave us a great idea of what we could do around innovation and technology going, not just looking at luminaire efficacy, but going beyond. So just to conclude, before I pass back to Bob and then onto the other presentations. So just to conclude where we were, so on the left-hand side is the graph about some of the step changes we took. But what we address is, yes, whilst luminaire efficacy absolutely is still really important, we have to strive to try and drive that through. We need to be looking at the full project efficiency. We need to be looking at how the environment can have an impact. We need to be looking at the distribution of the light fittings. You can have very high efficient light fittings, but if they're not delivering the light where it needs to be, or putting a lot of upward light onto a dark surface, we're not going to get the efficiency we need and maybe the light levels required. So thinking about distribution, thinking about the use of CLO, thinking about identifying the heavy areas within a space and an environment by understanding the operating hours, means we can then tackle those big winners, those big hitters, to really drive the energy down as far as possible. And of course, as part of that, we need to be thinking about the full system. We need to be going beyond just thinking about what the general lighting is doing and delivering efficient general lighting solutions, but what can we do to tackle the emergency lighting and the lighting control loading and the benefits that can bring. And finally, just I guess a question really just to finish. I haven't spoken about controls much today about the energy reduction savings, and that's absolutely key part of what we've got to do going forward. But another aspect of controls, of course, is the smart elements. And will we start to see smart controls come through, or is there an opportunity around smart controls to make sure that we get the facilities management part to work correctly? It's all well working through a project and saying we'll deliver this 36% reduction, but how do we make sure it gets applied correctly into the application, into the project? So, is there some opportunity around some of the smart control systems to drive that through even further? So thank you for your time. I'll pass you back to Bob, and look forward to the questions at the end.
Thank you very much, Tim. Well, 36% energy savings, that's an impressive achievement without losing lighting quality. And should also remind everybody, this is the first of a series. So as Tim has touched on, there's several other topics and things he hasn't been able to mention today, which he'll be talking about in his upcoming presentations. Next, I'd like to welcome Steve Shackleton of Fagerhult Lighting. Steve is a fellow of the Society of Light and Lighting, and he is Lighting Applications Manager at Fagerhult UK. Steve has spent over 40 years in the lighting industry, initially as a lighting designer, but latterly in management roles encompassing lighting design, systems design, marketing, technical and sales, both in the UK and Europe. And Steve's presentation today is minimum energy. Will we go the extra mile? Steve.
Thank you, Bob. And could you just confirm you can see my Fagerhult header slide and hear me?
Yes, we can.
Great. Okay, so I'm delighted to be able to contribute to this season of LightBytes, and what I'd like to do is look at whether, as Bob said, we might be able to go the extra mile in reducing lighting energy consumption, which I think is especially important because, let me just bear with me 1 second. Okay, that's better. Yes, so we might be able to go to the extra mile because I think lighting is a very big consumer of electrical energy. It takes about 18% of the UK's total electricity consumption, and commercial lighting consumes about 7/10 of that. And quoting Fagerhult's Chief Sustainability Officer, for now, our greatest opportunity to make a difference is in reducing the energy consumed by our luminaires when in use. And I also think we're in interesting times in lighting where energy use might start to rise again with increasing light levels driven, I think, by standards like WELL and EN 12464 and efforts to assist our ageing workforce with light, and also attempts to help with maybe circadian entrainment issues. So driving consumption downwards by every single means possible, and especially in a climate emergency situation, seems to me to be essential. So let's look at a few subjects that are hopefully worthy of consideration. And let's start under a heading of design. So our target illuminance in this typical recessed scheme is 400 lux, but as is often the case with a practical lighting layout dictated by a ceiling grid, the achieved illuminance is a lot higher at 510, an issue I'll revisit a bit later. Now, the fixed installed load in this case is 4.23 watts per meter squared. As Tim mentioned, these numbers are quite impressive figures compared to, say, 10 years ago, pre-LED, where perhaps 10 to 12 watts per meter squared would have been more usual. Now, the calculation for this project and scheme used a maintenance factor that was dictated to us of 0.8, which, without beating around the bush, has over many years become a default industry standard number, frankly, without a lot of basis in fact. And if we were to be more realistic and actually calculate the maintenance factor, the result would, I think, be very different. In this case, giving us a maintenance factor of 0.67, and that would, of course, push the initial illuminance upwards to 609 lux here and increase the installed load to 5.05 watts per meter squared. But also, it would likely give us a more honest appraisal of the performance of the scheme over time. And as is commonly the case with the maintenance factor calculation, the luminaire maintenance factor in particular is impacting the calculation, contributing to the over-design and excess energy use. But should it? Luminaire maintenance factors were conceived in the era of fluorescent and HID light sources and are, as our very simplified diagram shows, different to today's technology. Even in a clean office environment, it was common for a thick layer of dust and dirt to be deposited on the upper light emitting surface of the fluorescent tube, which of course absorbs light output. Today, premium quality purpose designed LED luminaires often have few, if any, upward facing light emitting surfaces, and they often make use of sealed chambers to protect the LEDs. Simply, the luminaire maintenance factor will be higher, and in this case we've used 0.9, which increases the calculated maintenance factor for our scheme. That means we can use fewer luminaires to start with, limiting the excess in design, and the installed load would be nearly 12% lower. Lamp lumen maintenance factors are also in the calculation and take account of the normal reduction in light output over time, but of course LEDs last longer than other light sources. If we were to use a light output value after maybe 70 or 100,000 hours of operation, the calculated maintenance factor would be reduced, so perhaps better to use a realistic expected life for the lighting installation instead. Quality LED office luminaires, for example, might only have reduced in light output by 5% after 15 years in a real-world installation, so better to use a realistic figure on these terms. Of course, it would be best if light sources didn't depreciate in light output at all, and this is where, as Tim previously mentioned, factory pre-programmed constant light output electronic drivers come in. These operate the LEDs at reduced output to start with, and then gradually increase power and light output as the years pass. And the result is constant 100% design light output through life, and a stark contrast with a conventional L80 luminaire, as you can see on the example on the right here. In our example scheme, this type of technology would increase the maintenance factor, giving reduced excess illuminance, a 6% reduction in installed load initially, and minimised energy consumption through the life of our scheme, effectively saving the darker grey triangle of wasted light and wasted energy. So, on to now another, perhaps mildly controversial, energy-saving technique for our scheme. We mentioned earlier that frustratingly common overlighting situation where the lighting layout is largely dictated by the shape of the room and the ceiling grid, but technology can present an easy solution. LED products can be factory preset to deliver just the right amount of light for a project with, say, the typical Type A fitting tuned to suit. That would certainly help a bit in our example, but I also think that's missing a trick. For the very best results, the Type A luminaire could be factory preset to deliver just the right amount of light in different parts of the same room. Type A1, A2, A3 luminaires, if you will, exactly the same luminaires, but preset to different and perfect light outputs for the room and the application. Unlike luminaires controlled by a dimming system, these factory preset luminaires cannot lose their settings or need costly recommissioning at some point in the future, and they can never consume more energy than intended or put more heat into the space, so the electrical and mechanical infrastructure can be sized accordingly and precisely with no wastage. In our example scheme, this would reduce the installed load by a remarkable 16%, surely worth doing, despite the undoubted challenges. And this is something we could start doing today in more or less any scheme. But you can probably see why this might be considered controversial. Yes, it's more complex for the supplier. Yes, it might cost a bit more. Yes, the wrong fittings might be installed in the wrong holes in the ceiling. And yes, there will be some differences in brightness between fittings, marginal in my view, and I suggest we can live with that. But also, yes, we're in a climate emergency and need all the help we can get, so perhaps we should stop thinking of reasons why these things might be hard to do and get on and do them instead. Once our space is occupied and we know where the desks are, controls can adjust the lighting to appropriately focus light without wastage. In our example scheme, control settings to deliver 400 lux to task areas and a pretty comfortable 200 lux in between could reduce the installed load down to just 2.21 watts per meter squared. Of course, an alternative way to provide such focus light is to reduce the overhead lighting altogether and then to supplement with task-oriented lighting for each workstation. Such task lighting could be desk-mounted or overhead luminaires aligned to the desks, and could also be individually controllable by the users in both output and perhaps even colour temperature. And this could have a significant positive bearing on the perceived quality of the environment and might even help us reduce energy consumption still further, as we'll discuss later. So there are some examples of how we could drive energy consumption downwards in design, and I'd now like to briefly look at two examples of how lighting quality can affect energy use. For simplicity, our earlier scheme example focused on conventional lighting using recessed luminaires, but evidence shows that workplaces lit using combinations of direct and indirect light are preferred by users. However, all things being equal, a DID scheme will tend to consume more energy than direct only. One way to optimize the balance of quality versus energy is to carefully choose the proportion of up and down light to best suit the application, and as Tim mentioned, to make sure that realistic reflectance values are used, which can often be higher than the typical 70% that we sometimes assume. A 30% direct, 70% indirect option might suit taller spaces and larger pendant drops, where it's perhaps best to desire to highlight architectural ceiling features or maybe emphasize the scale of a space. A 70-30 version, on the other hand, is ideally suited to lower height spaces to deliver efficient task illumination along with a lighter ceiling. Like for like, the 70-30 pendant would be around 25% more efficient for the same end result in the same scheme. To further maximize flexibility, the most useful pendant products have separately controllable outputs so that the direct and indirect components can be precisely tuned and even preset in the factory, as discussed earlier. Nobody likes waste, so having the ability to provide the desired task illuminance coupled with the lighter, brighter effect associated with DID, tuned precisely to suit the application and to minimize energy use, seems like another worthwhile use of LED technology. Okay, moving briefly to outdoor lighting, many manufacturers produce street lighting lanterns that have a wide choice of optics and outputs in the same housing, and these can produce multiple different light distributions suited to applications ranging from path and cycleways to even quite major highways. Generally, in typical residential street applications, a single luminaire optic is selected and rolled out across the estate. And I've got first-hand experience of this, of the effect this can have in a real life situation. Oops. This is an installation I know well. I'm looking at it now, and the newly installed LED lanterns gave an immediate and welcome uplift to the area at night, but there were some downsides. The same lanterns and optics were used throughout the locality and worked well on some sections of road and less well on others. Here, there's a surprisingly high level of vertical illuminance on the facades of some of the residential properties, almost akin to a bit of facade floodlighting, even though the houses are set back from the roadway. Now, this isn't the installation I'm referring to, but it gives an idea of the challenges with numerous combinations of straight, curved, circular and dead-end roadways, which are extremely difficult to light effectively with a single light distribution and output. Now, in relation to this, I once asked a highly experienced street lighting engineer why we don't install the most appropriate optic and output to best suit the immediate application, and they told me that it was a sound idea, but the practicalities seemed insurmountable. The wrong fittings installed on the wrong columns, insufficient records of what was installed where, and similar. Sounds a bit familiar, that, doesn't it? But I also asked whether there was any potential to save energy by doing precisely this, using the most appropriate optic and output for the immediate part of the road in question, and not wasting light by inadvertently floodlighting the fronts of houses or lighting some front gardens to road lighting levels, and generally helping minimize stray light. His estimate of the potential saving in energy consumption, 30%. 30% combined with better lighting quality for the residents and road users, and remarkable potential if we could only get over our long fixed working practices. So we've looked at some examples of how we might save energy in scheme design and around lighting quality, but a major way to save energy, probably the most important way, is to have suitable and effective lighting controls. For simplicity, our example scheme from earlier looked at installed load as a convenient measure, and we had driven that down to just over 2.2 watts per meter squared using all the techniques and technologies discussed. But here's an interesting comparison. This 40-story international headquarters building relied on none of those topics discussed, but instead made use of conventionally designed lighting combined with a daylight and presence sensing control system with sensors in each and every luminaire. The average installed load for the controlled lighting in this building is just 2 watts per metre squared, a highly impressive figure. But let's consider the benefits that controls could bring beyond those normal daylight and presence responses. And at the risk of going off track a bit, data has now overtaken oil as the world's most valuable resource, and lighting seems uniquely positioned to help us gather useful data. Wherever there are people, there are luminaires, and those light fittings constitute potential data gathering points, hence why lighting is often being referred to as the backbone of IoT, the Internet of Things. For good lighting quality, luminaires shouldn't be placed too far apart, and if each luminaire has built-in sensors, we can immediately begin to see how lighting could form a fine mesh of potential data gathering points that could help us amass data that is sufficiently detailed and granular to become really rather useful. So what could we do with all this data? Well, first, we could instantly share it with building managers to enable them to proactively limit energy consumption that is not providing benefit to users. Secondly, we could share the information with other building services. Familiar control interfaces like Tritium Niagara allow information to be easily shared to help guide decisions way beyond just lighting, moving into areas like facility availability, wayfinding, emergency guidance, and intruder identification. As humans move through spaces, office equipment is used, heat is generated, and of course, solar gains come and go. Precise movement, occupancy, and daylight information that can be instantly shared with mechanical plant can help to pre-prime heating and cooling, to smooth out variations, and allow plant load to be reduced at the earliest opportunity. Over time, a bank of highly detailed and highly granular data can be amassed that will help drive the efficient use of space as working patterns vary, and this can all help drive down energy use. And my final slide, we know from research that occupiers want control of their lighting, and this is known to bring increased environmental satisfaction and follow-on economic benefits to organisations. But perhaps more surprisingly, it also seems that when we give people control, the majority tend to use lighting less, leading to better satisfaction and lower energy use, a clear win-win scenario. Okay, that's my section over. Thanks very much for listening, and I'll hand you back over to Bob.
Thank you very much, Steve. That's some really good challenging of the status quo and a series of bright and pragmatic ideas. That's great. Our final speaker for today is Helen Looms. She's a fellow of the Society of Light and Lighting and a vice president of the Society of Light and Lighting. Helen works for Trilux Group with a variety of roles, including marketing strategy and innovation. She's deeply involved in the Trilux Academy, both coordinating at an international level and heading up the UK Academy. This gives her a good understanding of current topics within our industry. Helen has 40 years of experience in the lighting industry since her early years in a photometric laboratory. Helen is also involved with BSI and ISO, supporting global standards and communication on human-centric lighting. Helen, over to you.
Thank you very much. Can you see my screen?
Yes, we can.
Great, good. Well, hello from me, and I'm also very delighted to be here this morning. And with my presentation, I would like to show you that you can have it all in terms of energy, comfort, and sustainability. We just have to plan a little bit better. So for many years, energy saving was the most important market driver in lighting, and that will be continued in the future. At the Lighting Symposium in Bregenz in 2019, it was stated that the International Energy Agency reported that the energy usage for lighting in buildings worldwide had been reduced by 2% each year since 2010. But it's expected that only another 6% of energy savings is achievable from light sources over the next few years, which is slightly less significant. So we need to widen our scope from LED to lighting systems. A lighting system is a holistic one, with lighting components plus sensors, controls, and also includes the design of the system. They also stated that energy savings of between 900 and 1,000 terawatt hours by 2050 is achievable from optimized lighting systems with controls if we use them both indoors and outdoors. So recent research as part of the ReproLight research project, which I will cover in detail in the second LightByte, shows that 99% of primary energy demand consumed by lighting is during the use stage of its life and less than 1% during the production stage. This is the last column here, PED, or primary energy demand. And this part of the research was conducted by the Catalonia Institute for Energy Research. And this is the area that we really can potentially save the largest amount of energy, using the right light in the right place at the right time. And this has been encouraged by our standards now for many years, but the majority of people still don't consider treating the task and the surrounding area separately. The revision of EN 12464 Part 1 will push this further, and I will cover these changes in my final LightBytes series. So now I want to show you a case study of our offices in the Netherlands. A move to a completely new area in Amersfoort, just northeast of Amsterdam, gave the perfect opportunity to start from scratch and utilize many new ideas. As well as a working office, this location is used as a showroom and for holding seminars. So the temptation was to include more lighting than is truly necessary, and they did overindulge a little bit. All of the luminaires, apart from some accent light, spotlights, are HCL, or human-centric lighting, or circadian lighting, or integrative lighting, whatever you might like to call it. There are various sensors throughout the building that collect data on light intensity, air quality, and presence detection. In addition, all the luminaires are connected via DALI to our LiveLink light management system. Intelligent drivers collect all kinds of luminaire data, such as burning hours, dimming levels, and error messages via the cloud. Breakout spaces and circulation routes were fixed and treated to meet the required standards. Relaxation spaces were designed to have a differentiation, as shown here.
Helen, I'm really sorry to interrupt. Your slide seems to be stuck on the first one.
Oh.
I'm not sure if it's moving along for you there.
Yeah, it is for me. Let me try something else. Try just stop sharing for a minute. Can you see it now? I don't think that's
working. Your
working.
front slide.
Can you
try the next
see
slide?
it? Okay, let me stop again. Right, okay, so I've gone through loads of this stuff then. Can you see it now?
No, we haven't got your slides at all at the moment, Helen. Sorry.
Oh, goodness.
I can take back and give you back the presenter mode if you like, see if that'll...
Yes, please, that would be good. Right, can you see anything now?
We can, it just needs to go into the slideshow. Yeah, we can see that.
Right.
Awesome.
Well, I'm very
Thank you,
sorry. I've gone through 7 slides. So let me show you. This is the office in the Netherlands. This is the relaxation spaces. So you can see here there are some suspended discs, some of which are acoustic and some are luminaires. Then the cafe feel was enhanced by 3 suspended decorative luminaires. And there are sometimes jars of honey on this table because they also keep bees on the roof, and people are welcome to take them. Also within the scheme, the corridors were lit with linear lines of light, and some accent light was used for lighting the walls. Desks, however, are lit by desk-mounted luminaires that reflect back up off the suspended raft in the ceiling. And this type of task light is something that the SLL have been promoting for a very long time now. Decorative lighting was added in the customer areas and special attention given to the bar. And this level of hospitality isn't available in all Trilux showrooms, I have to say. But here is an area where you can see we are only lighting the space that is being used, plus some accent lighting on the walls. And the flexibility allows for meeting modules or a quiet space to be installed really easily. The user has control over their own lighting, but it's also linked to respond to daylight and the time of day. Employees are also given individual control over the temperature via a heated desktop and cooling from an integrated fan, and the lighting, both brightness and colour temperature, all from their individual workstations, which can also vary in height. Now, the impact of energy use must be considered when designing an office lighting installation. Building regulations across the UK require that the energy used should be controlled within specific energy targets, and these are usually the watts per metre squared that's been mentioned frequently by Tim and Steve. This can be achieved by not over-specifying the number of luminaires, using effective lighting controls, and using efficient luminaires. The connected load here is a lot higher than you would expect, but this is because every luminaire has 2 LED boards to give adjustability for the human-centric lighting, and we also wanted to display a lot of equipment, so we have over-specified. But this doesn't have a bearing of how much energy is actually used. So narrowing this down to the office area, here there is a connected load of 7.3 watts per metre squared without the desk luminaire. With the desk luminaires, this comes up to 12.2 watts per metre squared. But because all of the luminaires are HCL, the full connected load is never used. For instance, the cool setting gives a maximum of 5.5 watts per metre squared when connected, and the warm setting, this increases slightly to 6.7 watts per metre squared. But now if I apply the 50% reduction under Part L for daylight linking and presence detection, this comes down to 2.75 watts per metre squared and 3.35 watts per metre squared. I would love to be able to tell you what the actual usage is, as the control system does record all of the data, but it's not representative at the moment because the offices haven't been in proper use due to COVID. And at present it's showing less than 1 watt per metre squared. And a lot of this is because, as Steve said, the users very rarely set their lighting to the full 500 lux that they have the ability to do. Now, the percentage reductions that are allowed in Part L when using lighting controls are generic and would not work for constant lumen output type ballasts or when using complex lighting control systems such as HCL. Therefore, the more detailed calculation process should be used, namely LENI. This is the Lighting Energy Numerical Indicator, as mentioned by Tim. So what makes LENI so popular with the lighting sector is that it's a more holistic method to measure predicted energy in use. Underpinning the LENI philosophy is the imperative for good lighting design, as well as technical expertise, knowledge, and experience. And it's now possible to do LENI calculations fairly easily, even within Dialux 4. LENI embraces daylight, occupancy, operating hours, and the controls package to predict the lighting energy use in the building. And this method clearly differentiates between environments. So it will provide more accurate data for perhaps similar buildings in different locations that have different daylight examples. So in our Netherlands office, all of the data collected is clearly presented on a building dashboard located near the coffee centre. And the total energy approach has resulted in the project being awarded a good rating from the Dutch BREEAM certification. So we've just discussed an approach that is very focused on the end user. But can all of these new approaches and design-led thinking have an impact on a speculative office? Maybe we can address our biggest scandal, the disposal of hundreds of luminaires following a Cat A installation that is then changed by the incoming tenant. There is hope. Landsec are trying out a new modular design. The platform system uses a kit of modular components that can be combined to produce a customized structure. And this includes the lighting, and that's part of the module. And it can be interchanged to create an initial example while the building is marketed, and then modified to suit the incoming client's requirements. A trial led by Landsec, Brinewood, and EasySpace saw construction productivity improved by 55%, installation time reduced by 30%, and cost savings are expected to reach 33% when compared to traditional construction techniques. They claim that the result is a structure that uses less material, creates less waste, and has an almost 20% reduction in carbon impact. I think these are aims we should all be trying to attain. So I would love to hear your thoughts. Have some views from the audience would be great. So I will hand back to Bob, and let's hope we can have some interesting questions.
Well, stay on the line, Helen. That was absolutely brilliant. Thank you very, very much. And some great images there. I'd like to invite all of our speakers to unmute and turn their webcams back on as we take questions from the audience. Once again, if you haven't asked a question yet and something wasn't clear, something you want to ask, please use the chat function. We've already had some great questions. So if we don't get through all of the questions before the end of today's session, we will be answering them afterwards. Right, the first question from Michael Mann. Energy and comfort are really important, but so is carbon dioxide. How is this being addressed by Whitecroft and others? I'm referring to scope 3 emissions here, not just direct. So I think this is a question for Tim, if his Whitecroft has been mentioned.
Yeah, of course. Yeah, thank you. Yeah, so yeah, absolutely. We have, I think we've identified at Whitecroft, we've done great strides in helping businesses, drive down their scope 1, scope 2 emissions, which are the direct and indirect emissions from the energy they consume. And some of the work I'll talk a bit more about in the next session around what we do around the circular economy. We've done some great work and trying to understand our supply chain and the scope 3 emissions that our supply chain are also utilising with regards to their own emissions as well, and that wider embodied carbon element of the emissions targets. So we've done some work around circular economy. We're starting to do some work around the delivery of EPDs, such as the work around the TM, I think it's 65, I think, is it the CIBSE environmental impact we launched recently in February. So we're doing some work around that to work with ourselves and also our supply chain in understanding that scope 3 emissions. But it takes time to understand that data and information, and I think we're on with that. We understand we have to go beyond the operational carbon impact and help clients understand what our impact is as well.
I can bring in Helen and Steve, and stay with us, Tim. One of the questions we've been discussing as we've been putting these LightBytes together is that percentage between operational carbon and embodied carbon. So I know you were doing some calcs, Helen, you've got calcs on a particular single fitting, yes? So where do we think this number breaks?
Well, if we separate energy consumption, so our primary energy demand, from materials consumption, the energy demand in usage is very much higher than anything that we do in the production level. However, when you look at materials, it's completely the other way around. So we have to understand what we mean by embodied carbon. Are we going to combine the two elements, or are we going to keep them both as a separate identity to think about how we use our luminaires moving forward? Lighting controls are going to be our biggest saviour in as far as energy usage is concerned. As far as materials consumption, we are looking at so many measures to help reduce the materials we use in our luminaires, which I will go into in the next LightBytes series, and which Tim also touched upon in his project example that he showed.
From my side, I've seen quite a lot of different figures, but it seems very likely that the energy use in use is the big one. That's the one to focus on. But it's changing. I read something this morning that on Easter Monday, the percentage of renewable energy supplied in the UK was something like 80%. That's the highest figure ever. And it was because demand was relatively low, the sun was shining, and it was windy on that day. So we had lots of renewable energy. So things are shifting. We have to concentrate on it now, but the emphasis will shift to materials going forward. As we get more renewable energy, we need to be more and more and more careful about the materials we use, where it's sourced from, how it's sourced, and what we make light fittings out of, etc. And I know we'll all cover a little bit more of that in the next session. But we're in changing times, I think.
And I think that's the question to the answer to Michael Mann is watch next week. So we're talking far more on that. I know that's I'm ashamed advertising plug, but watch next week. Right, next question is from Graham Stone. Precision light output. How can you assume the right output luminaire is installed in the correct position by the installer? Quite a large opportunity for error. Judging by the look on his face, I think Steve realised this is probably aimed at him.
Sorry, guilty as charged. How can you assume? You probably can't. But what I would say is, not being able to put the right light fitting in the right hole in a ceiling is an important question, and we might get it wrong, but we have to stop getting it wrong because we've got a climate emergency. That'd be my I'm sorry, it's fairly glib, but that's, and I don't know how to resolve it. Maybe you put barcodes on fittings, and I don't know what you do, but it's a risk. But it's a challenge, I think, is worth solving because of that example scheme where we could save 16% energy consumption straight away without doing very much else. So it is a challenge, and I can't guarantee it, but let's try and do something about it if we possibly can.
Alan and Tim?
I agree, it's going to be a huge challenge, but I think we need to we need to draw our contractors and installers into this discussion. We should be working much, much closer with them. And I think if they understood why we're doing these things and the result reduction in energy usage and carbon and all that sort of thing, that they are also trying to do within their business models, they might be a little bit more willing to work with us.
Yeah, I think, yeah, just going on that comment again, Helen, I'd agree. You know, the work we did on that school, you know, when we presented the emergency lighting load, you know, to them, something they hadn't even thought about or considered. You know, there was proverbial falling off their chair, I think. You know, when we presented those figures to them, they just hadn't, because I think he liked it. It's the equivalent of having a walk-in fridge or fridge freezer every day for the same amount of energy was being consumed, having 365 walk-in fridges or something ridiculous like that, you know, in the amount of energy it's consuming. It just hadn't been thought about. We'd focus all on the general lighting, luminaire efficacy, lumens per watts, but actually there's this big thing in there. And I think, you know, we have to help educate people and help them understand what the opportunity and benefits are and make them realize, yeah, that potential that can be there, you know, whether it's emergency, whether it's reflectance finishes, whether it's distribution, you know, whether it's, you know, the other things that Helen and Steve have picked up. We've just got to be, yeah, advise and inform and, you know, help people make the correct decisions.
And I think, Steve, showing your drawing this is from Graham's question. If that was a large open plan office, the vast majority of the fittings were your type 4s. They're all the same. You only really have to start really engaging brain along the perimeters and in the corners. But I think your point was, if you can't put the right fitting in the right hole. But yeah, you're right. Just like we had on the street lighting, we need to start challenging skill levels, training levels, motivations, thoughts, and barcodes, all sorts of things are available to us now. We can track it.
It's key what Tim said in his presentation as well, that the improvements in LED performance are beginning to plateau. There's still a way to go, but they are beginning to slow down. So we need to do everything else in addition to make sure we keep driving down energy consumption, and putting the right light fittings in the right holes seems to me to be a problem that we could solve and reap the benefits.
Stay with us there, because your next question is directed to you, Steve. This is from Kevin Shaw. Steve, does the typical user turning down the lighting suggest we are generally over-lighting work areas?
Oh, it's a very, very, very good question. For me, no, I would turn lights up. You know, it might be something to do with my fairly high prescription glasses, but I generally like a great deal of light. And, you know, I've seen various pieces of research where, you know, the span of illuminance that people would wish to work under is huge, absolutely enormous, from thousands of lux down to tens of lux. But it seems also from the research that, given the choice, the majority tend to turn down, and the net result seems to be energy saving. So I'm not sure, Kevin, whether we're overlighting spaces. We're certainly not, for me, put it that way. And I think what we need to do is give people the opportunity. Maybe, I think Well talks about having you must be able to access a task light at every workstation. And that sounds like a good thing to me. So if there's enough light to stick a task light on the desk.
Yeah, I was just going to say the same. You're right, Steve. There's a section in there around controllability that says you must provide the option for someone to have double the amount of light required within the standards. So 12464 needing 500 lux, you need to give people the option to go to 1000 lux if they require it through. But again, that's through a task light approach, not from lighting the whole space to 1000 lux. You know, that would be through dedicated lighting, I think, would be the right approach.
And I think you have to do it within a certain time period as well, don't you? It's 4 weeks or something like that. Yeah.
Get that quick.
But I think what's really interesting here is that the new version of EN 12464 is not going to give us target light levels. It's going to give us a range, and we have to consider the user within that range, because, as Steve's just said, individual requirements are so different. And we need to be able to consider a really aging workforce, and they're going to get even older as time goes on. And your requirements for light it just increases dramatically. I mean, I also like a well-lit space because I'm older. But looking at the project in Amersfoort, the majority of the users there were between 30 and 45. So actually, the light levels that they all individually chose were lower than the 500 lux that were possible to have. So most people were using around 350. So the actual energy usage was a lot lower than the installation was designed for. But we also have some older people, and they need to be able to meet their own requirements. So it's flexible lighting. It's got to be the answer.
But I think just coming back on that, Helen, I think obviously what we've got to be careful we don't end up as a position where, because you can have a range of say 500 to 1,000 lux, that the specification just says 1,000 lux, please, in my Cat A installation, taking the less risk averse approach and then causing more challenges potentially in design and glare and all the other bits that might bring through by doing that. So we need to make sure we use these standards in the correct way to design in an appropriate manner, of course, and think about what we need.
We do, and that is the aim of EN 12464, to get people to think a little bit more, to not just go for these generic targets. And of course, our Part L and things will be pulling in the other direction, trying to get you to install less connected load. But there has to be a balance, and we have to make it right for the user, and then we have to make sure we use it in the right way to not consume too much energy, which is all possible.
Helen, another question from Kevan Shaw, and very pertinent to what we've just been saying. He says you're certainly heading in the right direction. How can we persuade building developers to adopt these kinds of complex lighting schemes?
Well, you know how difficult this is. It's not easy because they have different levels of focus. Their priorities are different. So they are considering the letting agent. How is it going to be easiest for the letting agent? And then when they have spoken to an incoming tenant, they don't want to wait months while the scheme is then changed to the tenant's requirements. They want to move in quickly. So that's why this modular approach that Landsec were telling us about was really very innovative. And it's sort of like rafts where the light fittings can be changed so easy, and some are done to give higher levels in certain areas, and others are given for lower levels. Some are wall washing, some are within a meeting room, but they can all be moved and changed really, really easily. And that flexibility was a hit with the letting agent and with the incoming tenant, so that they could both have what they want, and the changes weren't too difficult. It stopped all of that Cat A throw-out system. Be good if we could unmic Kevan. Is that possible?
I'm not sure.
I can give it a try. I'll just double check if he's happy to be.
Kevan, you happy to join the meeting?
Kevan's always happy to give us his opinion, but technology might not be on our side. No.
Just whilst we're waiting to see whether it can achieve that, can I throw in an auxiliary and pertinent question? And this is coming from Dave Battersby. How do you think lighting will change due to current prospect of more people working from home? More hot desk with individual control? Will smart centralized control also be able to handle all the variable data? And that also links into Steve's points about how much lighting people prefer. So
yeah, it's going to be such a huge challenge. We don't know what's going to happen over the next few months and years, but I think all comes back to this flexibility. You know, if we've got smart lighting, we could collect data on usage, where people are within the offices, what spaces are being used more than others. Does mean that some spaces might have to be redesigned. But then if the user can book a hot desk and then adapt that to their own requirements, this is going to encourage them to come and use the space in the office, because a lot of people have got very used to working at home, lots of daylight, complete control over their environment, and they like it. But there are advantages for working at home and for being in the office, and we've probably got to facilitate both.
Steve?
I think I don't know what the outcome will be, but I would hope we would end up with smaller, higher quality workplaces, exceptional quality workplaces, because I always think that if you owned a business and you employed 1,000 people, in the past, what you do is rent a certain amount of office space, and you get the using a standard calculation. But when are all those people in the office? And I think lighting controls can start to give us the data, the occupancy data going forward. And post-COVID, you know, maybe those numbers, if you've got 1,000 staff, maybe you only need an office that can accommodate 500 people in the future, because you know, because of the data that you've got, that this simply won't all be in the office at once. And then if that leads to higher quality but smaller offices, then bring it on. Fantastic. That would drive a great improvement. I think it also links back to Kevin's point earlier about how do we get developers to embrace these things. It's a bit of a challenge. I think the way we specify lighting in buildings is a bit of a tricky one, because the only way to do it successfully, I believe, is to specify the Cat A solution and a menu of Cat B solutions at the same time. So the designer is paid to do those Cat B solutions at the same time, those Cat B options, and then when a tenant moves in, they choose one of those, knowing full well it will be tremendously successful. So I don't know, maybe the way we design buildings, maybe the size of buildings and etc. will change going forward, and hopefully we'll end up with even better quality spaces. I don't even know if that answered the question, but anyway, sorry.
Well, we'll go to Tim then for Steve.
Yeah, so I think lighting will form one part of that change. I think there's an element we've got to wait and see what happens, and lighting is just one element of delivering, you know, effective spaces. And it's, you know, we'll need to understand more about, I think, as Helen touched on as well, you know, what we want personally will become really important. You know, ultimately lighting's there for one reason, which is for us to do what we want to be able to do, feel comfortable, feel relaxed, you know, feel whatever it might be. And I think, you know, lighting will do one of that. And, you know, as a lighting industry and community, we will work with the other elements of that built environment to deliver that. I think we can't do it in isolation. We have to work and be collaborative in what that ultimately becomes. What will it look like? I think, you know, no one quite knows that yet. Certainly some very good and interesting ideas out there, and we'll just have to see how that moves, I think, over the coming, you know, months and years in that respect.
Before, and we've got Kevin with us, but I'm just going to quick one comment. You know, spending so much of my life on screen, I've lowered the luminance levels around me, which seems a shame. But I remember Russell Foster saying one of the best things you can do for human-centric lighting was to go outside, go for a brisk walk to the coffee shop. Even better if you didn't buy the coffee. But I know, having been sat in my office here, when I go outside, that feeling of relaxation when you go out into the fresh air and the daylight, it's palpable. But Kevin, you've asked some really great questions. Would you like to join us? You're on audio.
Yes, I'm here. Well, I'll say thanks to everybody, because I think it's been very useful in illuminating points that have been brought up. Yeah, the discussion with how we actually get people to buy into these systems remains, to me, one of the big challenges. We've seen over the years that people like the British Council of Offices have started to adapt their thinking of lighting and their recommendations somehow, but we still find the letting agents and the people who actually run buildings, not the people who develop them, the people who then buy them and run them, just don't get it, and they just want simple and cheap as the only option that they provide. And they also demand ridiculous, 500 plus lux across the entire floor, which is just insanely wasteful of energy in this day and age. So how do we do it? And part of that, how can we make a cost argument, not necessarily on running costs, but on capital costs to implement these more complex things? Or do we have to push things like the building regs, which are in consultation at the moment for the next few days at least, to say, well, no, you need to be firmer, but not looking at product, but looking specifically at systems and how spaces are lit?
Can I ask you another question, Kavan? If we suggested that they did wall-to-wall, corner-to-corner blanket lighting for 500 lux, and that was all about marketing, lighting, and risk aversion. Build Back Better has taught us a new way of often working from home, and we have lots more people understanding the climate emergency facing us. Does that give us a method to talk to those clients and say the old ways were wrong? Building a 20-story office building and turning all the lights on so you can see that it's lit for its marketing purposes. Also, every floor can be moved into next week. Does it give us an opportunity to have those dialogues?
I certainly think it does. And I mean, having done it once a long time ago, we can do it now with the right developer in place. I mean, what we did on a significantly large office building is we actually designed the entire floor plate to 300 lux instead of 500 lux, and basically said, right, if you need 500 lux, then there's an allowance in the for the letting agent to be able to pay for or to give money to the incoming tenant to buy all their own task lights if that's what they wanted to do. In reality, what happened with the occupancy of that building is that most of the occupiers didn't provide task lighting and moved in as was, and it was incredibly successful. I think there was one case where one particular occupier insisted, waving a light meter, that there's 500 lux everywhere. So what they did, because we designed it as a constant luminance system, there was a control system. So they just went in, turned the entire control system up to full, and when the guy waved his light meter around, yep, 500 lux. Exact waste of energy. And we know, given 5-10 years down the line, that he wouldn't have had that because of lumen depreciation. So yeah, there are remarkably few people who are educated in that kind of thinking or prepared to take on that kind of thinking. And I think the argument is not necessarily even with the developers, it's looking at these letting agents, tenants, help with the BCO helping that to drive forward a different approach to lighting in offices particularly.
We do need to get a dialogue with BCO, and I think that's something we'd all really appreciate. We need to put a lot of effort behind getting them on board with this, because they have a lot of influence with the letting agents.
And I think letting agents are key. And I've seen many brochures for office buildings in particular over the years that sort of diminish lighting down to one sentence, 500 lux cap 2 or whatever. And that's not enough. That's that diminishes my career in my view. And it's interesting, Helen mentioned this in a previous discussion we had. If you go to Switzerland, which is the biggest freestanding uplighter market in the world, they don't fit out their office spaces. They simply put a few freestanding uplights in the corner of a room, and letting agents are able to come in and sell those spaces to potential tenants. And those potential tenants presumably have a leap of imagination to understand and believe what it's going to feel like. We don't seem to have that for some reason in the UK.
One of our problems in the UK is that freestanding uplights and desk lights are not part of the installed lighting infrastructure.
And that's the other problem.
Somehow we've got to get over that problem, that is it's a flexible, plug it in, unplug it, move it somewhere else type system, but it's probably one of our best ways of making the lighting more flexible. So somehow we've got to get over that problem of it not being part of the connected load. And
it's a problem with the system rather than lighting, and it's I don't know how we address it particularly, Kevin, and how we get over it.
Can I ask a question of Tim as well? And I know Tim's going to come in with the general point, but also, Tim, you were lighting a school.
Yep.
One of the problems we have with lighting, and Steve just said that people don't value lighting. They just wrote it down in these 2 lines. Can you engage the children to be part of saving energy? Any of us who've got kids or grandkids knows how fun it is to get them to turn the lights off. My children complain at me being too environmental, but can we make saving energy part of what they learn, and therefore they start to appreciate lighting, so that eventually that generation comes through and they give Steve longer than 2 lines in his specification?
Yeah, I think education is important around for everybody. I think not just schools. I think it's everybody understand the quality and value of light, and I'm sure we'll touch on that in the 3rd session. But I think not so much necessarily around energy. An example, I think you're right, Bob. I think it's encouraging that, and I think there is a shift in that generation of their environmental impact, and I think that's what we're seeing businesses change the importance about their own sort of net zero aims and aspirations and wider sustainability. But just to give an example, touch a little bit on the next session around that, where we presented about reducing the amount of materials in our products, and this was to a contractor, and he went and told in a meeting presenting it, looking at a flat panel as an example where we can reduce the amount of materials, and he went and told his kid this after our meeting about how we can reduce the amount of materials in our products, and his child was going on about it all weekend to him about how exciting it was that they can reduce the amount of materials in the products that we provide. So I think you're right, Bob. I think there's a generation of people coming through, but I also just wanted to touch on the point as well about, I think, yes, some people, there'll always be an element of I need to pay back as quick as possible, and that's all I care about, and it's a financial gain. But as I touched on at the beginning of my presentation, we do seem to have some interesting conversation with people who are thinking longer term and thinking of the longer impacts of what they're doing, both financially but also environmentally. And an example is the emergency lighting, where we presented that to an organisation, and we said, well, your payback, if you just look at energies, 6 to 8 years, and okay, there's a maintenance thing also that add the benefit anyway. And they said that's fine. We want to be looking 20, 30 years in advance. We're looking at the long-term aim now. We're not looking at the short-term gains that this can provide us. So I think there are some people out there who do want to listen and engage and understand what the opportunities are and the potential can be. And we just got to help educate others about what that potential can be and promote the benefits that lighting already has done, but what it can do still into the future.
Can you stay with us? So I'd like you to take a question from Mark Streeter. Tim, re-emergency lighting, is there scope to reduce the quantity of emergency lighting fittings through guidance, etc.? We see designers avoiding risk by overuse of emergency fittings.
Oh, yeah, now you're into a topic that I haven't. Yes and no. I think for me, safety lighting is important. I think it's, the first thing you've got to remember is why we do it in the first place. And I have an element of frustration with emergency lighting on people defaulting because it's less than 60 meters squared. I don't need emergency lighting. And unfortunately, I'm sure Steve and Helen, we and Bob, and probably a lot of people on this call, we see that all too often as if my classroom's less than 60 meters squared, hey, I'll take it out because the standard says I don't need it. It doesn't say that. It's used as a reason. Why is a 59 meter square classroom not need emergency lighting and a 61 meter squared does? But we've all been involved with schemes where they put it in the one and not the other. So I think, can we take emergency lighting out? I don't know. I think there's a level of understanding why emergency lighting is there, and taking that risk assessment and doing it properly. Not maybe defaulting because the standard says it, or maybe being risk averse. But I think it's it's a different topic for a different day, I think, Bob. It's a different discussion around the importance of safety lighting in the provision, and I think we have to balance, again, like I think we'd all agree, we shouldn't be compromising like quality for energy in general lighting terms, and I'm sure we've all seen examples of that where people just put LED products in for the sake of it, and we shouldn't be compromising on emergency lighting to compromise for that as well. But there's other systems out there. I think as we develop that, there will be other systems that might provide energy saving reduction whilst not compromising on that performance characteristics needed.
Thanks, Tim. Officially, of course, this session ends in about a minute's time at 12:30. I'm going to hold questions open for another 5 minutes or so because there's more to answer. Those of us leaving at 12:30 because you've got another meeting scheduled, please remember we're back on same time next week, 14th of April, where we're talking about minimum resource. Then that session is going to be chaired by Ruth Kelly-Westcott. But let's hold for those of you who can stay. I'm going to hold questions open for another 5 minutes. I can see another session coming up, Steve, on maintenance factor and the realities and what we have to do about it, how we address that. So, 0.8.
Yeah, it's that was the guest value 40 years ago, and it's still the guest value, isn't it? So we probably should do something about it, I would say.
Yeah,
you're going to
just on that. I mean, I've got some ideas around that. But.
I think maintenance factor is something that we could start to move away from as we start bringing in more control systems, because the control system does adapt for the maintenance factor in loads of ways. So your lumen depreciation, if you're just measuring the light needed within the room, so your daylight linking will adjust your lumen output to the lumens required to boost your daylight up to the level that you've set it to. So you won't need your maintenance factor if you're using daylight linked controls. That doesn't take into consideration the maintenance of the luminaire and the room surfaces. So we still have to consider those, but that's a completely different factor, and we still need to make sure that we clean things. But the actual luminaire depreciation from the lumen output, we can overcome by using proper control systems.
Yeah, I agree, and I think just on the room and the luminaire elements, I think we've been doing some work at Whitecroft for about the last 5 years now, where we've been measuring the reduction in performance, both the LED performance degradation, but also looking at the dirt build up in luminaires, and what we're finding in pretty much most applications. We haven't got a huge graph. We've got different areas we've taken. We're only seeing 1-2% in sort of traditional 600 by 600 products, downlighters, surface fittings. But you look at the standards within the SLL, for example. they're talking about 10-12% reduction for some of those types of technologies, touching what Steve was talking about before with the way they're designed previously. So I think there is something we can do to still factor it into our designs, but maybe be more sensible about what it is. And I think I have seen recently, I seem to see a bit of a trend recently in specifications where people are almost going the other way now. They're almost being too conservative. And I've seen those specifications putting through a blanket 0.7 maintenance factor without understanding the quality of the products that are installed, understanding the operational lifetime of the installation. So you're almost going the other way. They're almost using maintenance factor as a risk-averse approach to designing to make sure they've got covered, maybe because this mindset of LEDs last for the life of an installation. So I need to make sure I'm covering myself in that respect without maybe look at some of the other factors and variations as Helen mentioned about how products perform and how we can maybe challenge the numbers we have around us today.
It probably would justify another full session, Bob. You're right. Just one interesting diversion. As we dim fittings, as we response to daylight, as we switch them off in response to presence or dim them in response to presence and occupancy. What I was first told about LEDs is the big killer is heat, and of course if you dim them, the heat's going to reduce. Now, what I've never been able to get is a really solid answer about how does that extend the life of LEDs over time. We know it does, but how much does it, and how can we put that in maintenance factors, and how can it help us reduce energy consumption? So I don't know. Maybe maintenance factors due for a big shake-up in total. I don't know.
Well, stay with us because I'm going to ask the final question of today's LightBytes session, and this is from. My apologies. This is from Peter Fordham. And Peter Fordham says, CLO drivers, they're great technology. Do your watts per square meter figures account for the lifetime increase of load, i.e. are they at day one or at end of life?
Can I go first? So in the example I used in the school projects, we took the average with the mean across the project. So the reduction factor we took into account wasn't day one, wasn't end of life, it was in the middle, so it took the average because it is fairly linear with LED. So that's within our application, that's the way we applied it into that design.
And that's pretty typical. I think it does vary between suppliers, but that would be pretty typical that the mid-range, the average would be the figure that's taken.
And this is one of the areas you could use your Lenny calc.
Well, I've got one final question then, because this is from Paul Stearman. Now, Paul Stearman is a tutor at the LIA, so I don't know whether this is slightly tongue-in-cheek. But does the panel think that Lenny is too complicated to calculate?
Yes.
Yeah, it is, because the calculation itself is just putting, and Dialux can do it for you. It's finding those numbers that's really difficult.
That's the problem.
So I think that's one of the reasons I didn't do the Lenny calculation for the Amersfoort office, because I've got no data on how often they will be there. It's your hours that you're using that's really, really hard to find out. So, like with Tim, you said with schools, you did have some certain parameters that gave you guidance. And I think within offices, it's much harder. And I think following COVID, it's going to be even harder because people will be coming into the office less. So, yes, it's almost impossible to predict how often you're going to use your lighting.
I think also,
sorry, Tim.
Sorry, Steve. After you, Steve.
And I think it just shows the power that we've got at our fingertips in gathering data from lighting. All those lights and all those potential sensors that are measuring stuff in our buildings, that could really give us really powerful sets of data that we can use in new designs going forward. And you're right, Helen, getting the information is the biggest problem. But maybe with that sort of information, armed with that sort of information from a similar previous project going forward, you've got a better chance of having better predictions and buildings performing as intended.
You're right. I think just finish off, just touch on both those points. Yeah, I agree. It is quite complicated. I think the actual Lenny document is about 10 pages, 12 pages long, and then there's about 70 pages of appendix, of which most of that is daylights. So it isn't easy. But I think you're right. Touching on Stephen and Helen, it's some way. The Lenny is important to understand how it performs, but I think it's what it actually performs in real life, in reality, once it gets installed and once it gets using and operating. It's all about having a theoretical position, but we need to understand it better, and that possibly is where smart controls and analytics and data and understanding can know whether the building is performing as it should do. Is it better? Is it worse? Is there more we can do? And without knowing that, it comes harder to really drive down the energy consumption, I think, in projects.
Right, I'm going to draw an end to the questions there. There are some questions we haven't answered, so we'll be coming back to the questioners directly. Thank you very, very much for joining today's session of Society Light and Lighting's LightBytes Online. Huge thanks to our three panel members, Helen Looms of Trilux, Steve Shackleton of Fargo and Tim Bowes of Whitecroft. You've been absolutely brilliant. All three of them return next week, same time, next Wednesday at 11 o'clock. So please join us then, when they'll be focusing on minimum resource. And as I said, Ruth Kelly-Waskett will be chairing that session. So we look forward to welcoming you back online then. And as previously mentioned, a link to this recording will be sent out shortly. So that only really remains for me to say thank you for joining us and enjoy the rest of your afternoon. Bye-bye.
Thank you. Bye-bye.
Cheers.
Thank you. Bye-bye.